Last time we talked about enumeration. What's enumeration do? You can get both the index and the value in a list as you loop through it at the same time. And we also talked about other cool looping things, such as, remember the whole picture example?
Nested blocks.
Yeah, we talked about nested loops where you did you figured out how to print the numbers 20, 21, 22, 30, 31, 32. And then we talked about going down inside of directories using the walk function. It was an OS method. And we talked about creating a list from a list by changing everything in the list the same way every time, which is called the Python structure that allows you to do that is called a list comprehension. Yeah. So the time before that, we talked about debugging and finding your bugs and rooting them out and trying to get rid of them. And this time we're going to talk about a slightly different technique. Some bugs you do need to root out and get rid of. You need to change your code to remove the bugs. But some things are out of your control, mostly things that come in from the user. You can't necessarily predict ahead of time what they're going to be passing into your script. Or also, you don't necessarily know what the quality of the data is that's being pointed to. So these are the kinds of things that you want to use this structure in Python with the keywords try and except, which is called handling exceptions. What's the error message that's coming out here? What kind of error is this throwing? It's a type error. That's the name of the exception. Can you see why? The line of code that it's referring to with the type error is this one. This is our loop. We have raster list, which we get from list rasters. That should be returning what? A list of rasters. It should be some string names that you can then loop through. But this is saying none type is not iterable, and usually iterable is the thing that's the list. So there's something wrong with our list. But we've just used the standard argpy.listRasters, which is okay. You don't have to pass any arguments in. You're just expecting to list the rasters where? Which set of rasters will it be listing? Whatever's in your workspace, assuming you've set your workspace up properly. Have they set their workspace in this script? Yes and no, right? Yes and no. They tried to set the workspace. The intention was there, but they spelled it wrong. And actually, this is a mistake that I found on the Esri forum. Somebody posted their code and said, I can't understand why this isn't working. It doesn't warn you that you haven't set your workspace properly. It tries to list rasters in a workspace that hasn't been set. The initial value of the workspace is an empty string. When it does list rasters on an empty string, it returns none. And then it's trying to loop over none. It's trying to iterate over none on this line. Suppose we fix that problem, we put our k in, and then we try to run the script. We know that it's taking some unit of measure, so we pass in, say, 0.001 meters, in quotes, which means that it'll be a linear unit with a space in between it, which is cool if you're trying to do, say, a buffer tool or a distance tool or something like that. But then the script takes that argument and does what to it? Tries to cast it to float. That gives a what type of error? A value error. Why? You can't cast this string that contains non-numerical characters as well as a number. It's not intelligent enough to say, like, oh, you meant the first part. So it's going to give you a value error on that. What I was indicating earlier is that the first exception that we found here, this mess with the raster list, that's the kind of thing that we need to repair in our code. But the second kind may be one that we want to handle more gracefully. And there's nothing we can do about our users not knowing what they're doing. In some cases, you want to just inform the user of what they need to do and gracefully exit. You don't usually want the user to have traceback errors coming out at them. This is for when you're thinking of sharing your code with someone else or using your own code 6 months from now. You can tell yourself, oh, this is how I was supposed to do it. As I said, the first error is the type of error that should be corrected. The second one should be handled. So by handled, we usually mean we're handling user input or data issues like locking or corruption. By handling, we mean we're going to use these Python keywords try and accept. So if you look at pretty much any programming language, it'll have structures of this ilk. This is a common thing to do. If an exception occurs inside of a try block, so we have the try, we have a colon, we have indentation, the rest of the try block is skipped and execution jumps to the accept block. If you're walking around with your cursor and you got to this line float sys.argv1 and it didn't work, it would jump down to the exception and it would print, an error has occurred, please enter a numerical argument. And then it would go on to whatever else is in the rest of the script. It wouldn't, though, try to multiply 2 by the number, which doesn't exist, which would also throw an exception. But if no exception occurs, the except block is skipped entirely. For example, if the input is 5, the script will go in here, cast it to float, multiply it by 2, and then print the double number is 10, and then it'll go down to any code that follows that that's not inside of the except. So it's a bit like if and else, in the sense that if the if is qualified, then you don't go into the else. If the try doesn't fail, you don't go into the except. For a try, there has to be at least one except. So it's not like the if statement where you can either have an else or not have an else. You don't have to have a default condition. If you have a try, you have to have an except or finally. We're not going to go over finally. We don't need to go over it. Use at least one indented line of code after a try and use the same indented line of code after an except. If you have a try word, you have to have an indentation right after it. And an except has to be an indentation after it. That's the same as all these other blocks of code that we've been playing with. We had the if and else. What else have we done that's blocks of code? With the for and the while, right? You have to indent. The first line after a for statement has to be indented. The same here. So you want to put the code that may cause an error inside of the try block and put what to do in case of the error inside the except block. Make sure you put your colons. There's got to be a colon after a try, colon after the except. The code that is dedented, that comes after an except, is executed no matter what. If the try goes all the way through, this gets executed. If the except gets reached, this still gets reached. The other thing is that an except block can optionally specify the name of an exception. Like in this example down here, it says except index error. So that's specifying that this exception is specifically for handling an index error. If another kind of error occurs up here, then it won't go into this except block because it won't be qualified to go in there. This thing about code dedented after the except block occurs no matter what, that means that sometimes you may want to use a sys.exit. I don't want to encourage you to overuse sys.exit. You only need to use it when the code explicitly leaving without doing the rest of the statements. The top example, imported sys and argpy. We're getting input argument, which is the thing we want to buffer here. We've got it inside of a try, and we have an index error exception, which will print the usage. Usage just means this is how you're supposed to use the script. You need to pass in input data set. Line 7 does the buffer analysis. What'll happen if we have an exception here? Suppose the user doesn't supply an argument. It'll get to line 3, it'll say sys.argv1, and it'll throw an index error, or because we're trying to index beyond the end of the sysargv list. Where will it go then? Line 4 and then line 5, and it'll say usage, input workspace. And then what? It's going to go to line 7, and it's going to try to buffer input, which hasn't been assigned, which would be bad, because the whole point of this was that you were trying to avoid throwing confusing errors at the user that they won't be able to understand. In this case, we don't want to do the buffer analysis if the argument is not passed in. We don't want to get to line 7. That's why in the second version of the script, we're doing a sys.exit, which means that the script will exit without executing any more lines of code beyond that. And whenever it reaches that, it's done. There are different types of exits that you can send in. Sysexit 0 is normal. So when stepping through with the debugger, by the way, even if you have this code, which is going to protect you from seeing the index error, if you're stepping through with the debugger, you will see the exceptions printed out, which is a good thing because you're trying to debug. You need to see the exceptions. How about using named exceptions? There may be some times where you want to handle more than one potential kind of problem. For the named exception, if there's a value error, for this example, that it will go inside of that block. But can you think of another error that might occur? It won't go inside of this except? Yeah, like an index error, right? Like we had in the previous example. If an index error occurs, it's not going to go into the except, and it's just going to print the traceback message as usual. The code, in this case, it's not catching any other type of exception, but you can catch multiple types and have different things happen based on that. What it involves is kind of knowing what kinds of exceptions you want to handle, what would be the common problem, not providing an argument or providing the wrong type of argument, or passing in a file that can't be opened. What you need to do is get a little bit familiar with the exception names so that you can then handle them. How do you know what name to use if you are wanting to handle some kind of exception? You can create the exception. For example, dividing by 0 is not allowed in Python. We need to make sure if there's a division that there's no division by 0, and if you want to have an except block for that, how could you find out what's the name of the exception that you would need to handle that with? Yeah, just do it, right? Go into your interactive window and say 1 divided by 0. See what happens. And it gives you something like this, right? So this would mean you would need to say try A divided by B, and then accept what? 0 division error, right. The other thing that I was saying earlier is that you can have multiple except blocks with named exceptions. You can have any number of except blocks with one try block, sort of following in that same block. You can have, however, only one unnamed except block with a single try block. It's your default condition. That's where it's going to go should none of the other named exceptions apply. So when an unnamed except block is used with named except blocks, the unnamed except block is placed last, and that's where it goes if there's nothing else applying. A try block needs at least one except block, or a finally block can be used as an alternative to an except block. Finally keyword is actually not going to be covered in an upcoming chapter. I lied. So here we could add an except down here to this one. We're going to do an in-class exercise, which involves assuming that you're looking at the workspace that's shown here. You're going to look at this script that is being distributed, and it's this one on the left, and you're going to figure out, based on these different argument input scenarios, what would be printed by the script. So it's a matter of dicing out these try and accept blocks and the flow of the code, and also the conditional statements. The arguments that you want to try out at the bottom, So say you pass in no arguments, what will happen? If an exception does not occur in the try clause, execution of the try clause is finished and the except clause is skipped. I already said that. Okay. If an exception does occur during the exception of the try clause, the rest of the try clause is skipped and execution jumps to the matching except clause. So just keep those facts in mind as you're doing this. If we step through it with a debugger, what's going to happen after I step over line 5? I haven't put anything in the argument window. I'm going to have throw an index error, and since I'm walking through with a debugger, we'll actually see the index error in the interactive window. An index error there, and then it's going to go to where? Line 11 and line 12 and print, and then it's going to go where? It's going to exit. And it does throw a traceback exception, but that's normal. If you do a system exit, it throws that. And this is that returning exit code 0, because we got out with a sort of a normal exit. Okay, so everybody got that right? Doh! Okay, what's next? Bogus. Okay, bogus, it says bogus doesn't exist. By the way, you know they have this connect to the folder thing? And it's like a whole tedious browsing because they have the old-fashioned Windows. If you just copy and paste the directory, if you grab it from Windows, like this path, and copy it and paste it in here, it connects it. What are your answers for this one before I run it? Hooray and meh? Okay, let's see. So we get to here. There is an argument, so we print hooray. And then we describe the argument, but it doesn't exist. And it actually throws an IO error when you try to describe an argument that doesn't exist. So that's why. Did you guys try it out? Is that how you figured that out, or you just guessed correctly? Yes. Yay, guessing. Okay. So it jumps down to this IO error, it prints that. And how comes it doesn't print at last? Yeah, it exits just before that. So that is done. Notice it takes a couple extra clicks to finish the run. So hooray and meh. And then tree.gif. Seems like I don't have that, and I wanted to. Do I have it? You saw it?
On the slide it says tree.gif.
Oh, there it is.
Where it says tree wraps.
Yeah, there it is. Well, on the slide, oh, does it say something different in the green area down there? Oh, okay. Well, the data I have is a tree, is named tree, so I'll just run it that way. Okay, so tree.gif, and if I go, what's my prediction for this? What? Hooray, whoopee, ooh. Hooray, whoopee. And then we try to find the shape type, and then what happens? It throws an exception, and in this case, because the describe object is describing what kind of file? Raster data set. What happens with this? Yeah, rasters don't have a shape type. This object that you're trying to do a dot shape type on does not have that attribute. Attribute error. Boom. So it's going to go where? That's where it gets down. So it checks on these, it doesn't qualify, and then down to 18, and ooh. So you saw how it was stepping to 11 to 14, just because it's like checking, is that the right one? And then it's exiting. cover polygons, .shp. Hooray, And whoopee, yeah. And it's going to like this, right? So fab, yep. Then what? Yeah, then it's going to skip down to line 21. So data shape type equals polygon, and it's doing something. Yeah, so it would be LOL. Okay, so I went from line 24, and I forgot to ask you what came next, but it was happy, right? It didn't throw an exception, and it also didn't go into the elif, right? Because it went into the if, and so then it went all the way down and printed toodles in that case. Did you guys have that one right? I heard you talking about toodles. Fire points. Okay, so what's going to be printed with fire points? Okay, sorry, I got to catch up to you. Hooray, whoopee, fab, and then you said few. Okay, that's a relief. And then Shazam, yeah. And why does it print Shazam there? Because you're still in that elif block. You happily went past the except to the next line of code that's in the elif, and then you're going to print toodles. Okay. Okay. And for the last one, I have polygon or park lines on the sheet here. And what do you have? Hooray! Whoopee! Fab! And then it doesn't go into there because it's a polyline, and it doesn't go into here because it's a polyline. So that's where you came up with your solution. Good. Kyle was asking me about line 27. How could we get it to go to line 27? Or how could we get this current script to go to line 27? With running one of our inputs. What? With what? Which same argument? I just ran it with 10 different arguments. 6, actually. Okay. Cover polygons, says the back of the room. Okay, so let's try it. Doop-be-doop-be-doo. And then we get an execute error. Has anybody seen an execute error when they're writing their code? So we don't print LOL because that error occurred on line 23. So that means we go into here. It's an arcpy execute error, which we're going to talk about in a minute. And then we print uh-oh. And this is an arcpy thing that we're going to talk about in a minute too. So arcpy has its own function for printing out messages. You can say get message or get messages. And if you use the get message version, you can put an index in there, and that'll select which one you want to print out. So get message count is another arcpy function that gives tells you the number of messages there are to index. So if I am indexing into get arcpy.getMessageCount -1, what am I getting? The last message. So let's see what that is. Right after uh-oh in the window over here. Failed at Tuesday, Feb 16th. Right, so that's the last message in it. So if I were to say, go over in my interactive window and say, get messages and get all of them. Whoops, I guess I didn't do tab completion. There we go. So it gives me this sort of all-in-one blob. Or I could say print. If I say print arcpy.getMessages, it formats it for me. And then, so do you see the carriage returns up here in the original printout? Maybe I should make it bigger. If I just said arcpy.getMessages, it printed it out without it interpreting those escape sequences. So yeah, so anyway. So this is, if you print it out, it interprets the escape sequences, puts things on separate lines. And see the last line? That's the one we printed out before. So it gives you a way, like, if you want to just get specific information about the message. So this is just the kind of information they return. So executing, what is this line telling you, do you think? Remember, this occurred after we stepped over line 23 in our script. Let me see if I can get these both on the window at the same time. Okay. So executing, it's telling you what tool, right? Polygon to line. Here's the name of the tool. And what do you think this is? The input. Yeah, it's the first argument. It's the first argument. What's this one? The output. It's the second argument. What do you think this is? It's the third parameter. It's the default value for the third parameter. So it's telling you how it ran the tool. It ran the tool with these arguments, or these parameters. And next line, start time, that's pretty self-explanatory. Failed to execute, that's the bad news. Here's a little bit of information. Parameters are not valid. Error, output feature class already exists. Okay. Failed to execute, and here's the time. So it failed to execute polygon to line. And so, yeah, that's the kind of information you can get from there. All right. Don't record. Moving on. So that's what the next slide has to do with, named exceptions for ArcPy. So there's so you can say arcpy.execute error. I don't know if you noticed that in the script that I passed out on line 25 and line 32. It says except arcpy.execute error, and that's the way you can specifically catch named errors for tool execution. So all of them are called execute errors, and then they have specific things they say that went wrong. So here's an example of how you might use it. Pretty straightforward if you've got just a plain script that's calling one tool. We'll go in a second about how to do it with looping. Here's another close look at the error that this one throws. It's the same example that we used before. It's a little tidier than seeing the traceback message in a way, but the traceback message gives you the error near the bottom, the same error near the bottom. Right? The saving grace of printing out arcpy.getMessages is that at least it's not got all this traceback information, so your kind of user won't be confused by all this. Sometimes try and accept can trip you up when you're developing code, because if you have an unnamed accept block and you have an error that is not the thing that you expect it to be, you won't see that traceback message unless you're stepping through the debugger, but you won't see that traceback message to tell you that it's not the error that you think it is. That's why the traceback module is useful. It's one of the built-in Python modules, so you can import it just like you can import sys or OS. Here's an example, which is the disaster, right, that you don't want to occur, which is that you have some code up here that messes up, and then you have an exception that is handling probably something else, and it prints out useless information, and it suppresses the traceback error that would inform you what's actually going wrong. So for debugging purposes or for development purposes, it's nice to have the traceback imported, and then you can print out the traceback information. Here's a couple of examples of how to use that. This would tell you if there is an exception, then you print the exception. This line of code, unexpected error type exceptions dot zero division error, is printed by this line. So it's printing out what's the name of it, and you can print the traceback message, force it to print out by using this line. So you want to use this traceback.print ex_exe in your code when you're developing it. So I think it takes whatever traceback is in the stack. I'm not sure what it looks like, but the arcpy.getMessages will print out whatever the most recent tool execution results were. So if it was successful, it'll give you that, or if it was an error, it'll give you that. So you may, if you've got an arcpy script, you may want to also include print arcpy.getMessages, and that'll give it to you in a nice, tidy format. Okay, so in this case, except is hiding the true error if your user forgets to pass in an argument. So if your user forgets to pass in an argument, it's going to get to this point, throw an exception, get into the except, and print input must be numerical. So it won't tell the user, oh, you forgot to put input in there. It's just telling them that the input has to be numerical, which isn't quite directly to the point. So this would help you by printing out what the exception is, and then you can see, maybe I need to add an index error catch for that. With exceptions, when you're looping, if you've got a tool call inside of a loop, you need to make sure that you put the exception catch inside of the loop. Why do you think that might be? If you've got a loop, say you're looping over some input data, and then there's something wrong, like a corrupt file in your input data. If you've got a script that you want to keep going after that, you want to catch it and then go on and unbuffer all of the other ones. If you go to today's in-class, you have to roll down, because I've got a bunch of other in-class exercises before that. But there's buffer loop try.py is there. And then there's another one, buffer loop 2.
Yeah, I know. So
Buffer loop try 2. So the idea is to copy buffer loop try into a new script. Make a bogus shapefile, which you know that you can make a bogus shapefile just by creating a text file and naming it with a SHP extension.
Go here and right-click and new text file, new text document, and then paste that name in there, and then get rid of the TXT extension. So now we have something that is a shapefile by name, but it is bogus. And so we've also got cover 63p in there, and it is valid. And so we're going to predict. So when we run the script, okay, so what? All right, so let's make this a little bigger.
Well, what's the argument supposed to be for?
That's what I was wondering too. So maybe it doesn't need arguments. Let's look at
Here
this.
the workspace set.
I'm sorry?
These supposed to be capital letters. So it is the workspace.
Oh, you're saying capitalized?
Yes. I mean, I'm sure that's set like this for purpose.
Oh,
But
okay.
I mean.
Okay, so here we put the path as the first argument, and then we put the feature class as the second argument. So, and run the script, predict what will happen when you run the script, and then run it with no debugging. And so I'm thinking that it's predict what will happen when you run the script with that bogus name, because that's what she asked for. So let's try to predict it. So it'll go here and it'll say I equals 1. So it will go into the loop, and it will try, and it will. So that has the effect of stripping off the extension. So this doesn't tell us. We're guessing that in line 4, you want us to predict what will happen when we run the script and we pass it a parameter of ctemp and a data.shp.
Okay.
That's what we're supposing.
Okay.
Okay. Yeah.
What will
So,
happen if you don't?
we would get a uncaught exception at line 8 of an index error. So we predicted that, right?
Yep. Good.
Okay. All right, so now run it. With no debugging. And we're going to run it just like that, with no arguments.
You're up the steps through. Yes.
No debugging. And where is the interactive window? It's over here.
Yeah. You give it a.
So that select all and delete, and let's run that again.
So we're running it without the arguments to start with.
Yes. And so we were right, it produced the index error. Run the script again using the step through and the debugger option. Ideally, we want the script to create buffers for all the valid files. Just print a warning if it fails for one of the files. Try and accept are in the wrong positions for this to happen. Repair the script. And this time we're going to step through the debugger. Step through in the debugger. Okay. All right, so we want to step into it with no parameters, but with debugging. And so now I'm going to step by hitting the step over icon, and it's importing everything. And now overwrite output is false, workspace is set. Okay, so there is the index here that we were expecting. And so we need to put a try except it's an index, right? What's the name of that?
Column.
Whoa.
Print.
Sorry, I'm getting the number of, I'm trying to get the correct number of
It's still going to mess up.
because that's going to cause an error if I have that wrong, and I have it wrong. Okay, so index error, print, usage, path, and shapefile name. What do you think?
Seems intuitive.
Okay.
And then you need to do the system action.
Oh yeah. Sys dot exit.
So that should.
Okay. All right. So let's go back to this and let's see if we're doing what we're supposed to be doing. So we're down to 7. Predict what will happen when you run the script and run it again with no debugging. So we think that it's going to come down here, print out the required usage, and then exit.
Right.
Okay.
That's only if there's no arguments.
So I'm going to run it. Yeah, with no debugging, and do that. And usage path. Okay, good. I'm just going to add.
I think I gave extra time, so we'll have to see.
Oh, yeah, there's a class.
I think it's longer than our classes, our usual class period.
Oh, yeah, I need all of it. I can't take it. Well, there's something before us.
There's,
Have you seen me?
But it might have to be like right between us.
They have a schedule. Except the ending one's not. So you like write a whole script. That'll be what I'll take.
Okay. So now we're past that, and so now buffer has a value. Sorry, y'all.
Oh, we were talking about doing the A-class exercise.
Why is this happening?
I don't think you can copy in there.
Oh, yeah.
what happened?
Okay, so buffer has that name. Okay, and so step and attempted, failed to execute. So we.
The kinds of evaluations that I'm doing in class is pretty much, hey, if I can't see it for sure.
Yeah, we import ArcPy.
If I can't tell the difference between your uppercase and lowercase, that.
Okay, so it is going into the exception block.
Hey, I like my, I don't want to take my.
So now,
I can't tell what's going on here. Is that what you're asking?
okay. All right, so it's going to fail every time. Tools. All right, so it's going to fail every time. So next, we're going to try it with cover 63P shape.
The reason that they do
clicking through, and it seems to be running. So I'm going to continue. So I clicked on continue, and it continues to run. Okay, so there, I guess we're done. You following that?
Yeah.
Okay. All right. Well, I'm going to pause.
This slide contains the solution for buffer loop try. It's useful to look at the original script side by side with the solution. The original script is here. So in this script, we get the list of feature classes, and then the try and except are here, with the loop happening inside of the try. This would be ineffective if one of our calls to the buffer tool fails. An exception will be thrown and it will be caught. However, we won't continue to buffer all of the remainder of the files in the list. It will be thrown and it will step out to here, and then the code will terminate. What we really wanted to do is use try and except in a way that we could have a corrupt file in the middle of our list, but still do the buffering on all of the rest of the files. So the solution on the left here moves the try and except inside of the for loop. For FC in FCS, try, and then put the geoprocessing followed by the exception. That way, if we go through, get to a bogus file, it will be thrown out to this except, but then it will continue to loop through. Now, buffer try 2 has a different issue. Buffer try 2 shown here uses a while loop, and that can cause other problems as well. In this case, the main issue is that the update is inside of the except. If we indent this update into the except, that means, okay, well, at least we've got our looping, our try and except inside the loop, and we've got our tool call inside of the try. But once we get to the first tool call that's successful, we're not going into the exception, which means our X is not going to be updated. So we'll get stuck in an infinite loop of wherever the correct or the non-corrupt file is, we'll get stuck at that value. So in the case of the while loop, you need to make sure you dedent. We changed the variable over here from X to dist. That doesn't really matter. It just was a more descriptive name. We're updating the distance value. But if we dedent that, then we have the while loop is going to truck along correctly. So in the case of the correct or the uncorrupt file, a good file, we're going to loop through here and go ahead and update our distance. And in the case of a corrupt file, it'll go here, try to buffer, fail, print out a message that it couldn't buffer, and then it'll still update our dist variable. So in this video we discussed handling exceptions versus fixing mistakes in the code. So there are some exceptions that need to be handled. We went over the try and except keywords and how the flow of the code works when you have those in your code. We discussed named exceptions and the traceback module. The next video on a new topic will be on user-defined functions. Some other related topics under additional topics there that we're not going to discuss here, if you want to look into those in more depth, are assert, raise, and finally keywords that can also be used with exceptions, and you can also define your own types of errors.